am Sunanta from SNS College of Technology. So let us see a case study on differential equations in this video. First, let us see what is differential equation. Differential equations are introduced in different fields and its importance appear not only in mathematics but also in engineering, natural science, chemical science, medicine, ecology and economy. In mathematics, ordinary differential equation is a differential equation containing one or more functions of one independent variable and its derivatives. The term ordinary is used in contrast with the term partial differential equation, which may be with respect to more than one independent variable. Now let us see notations and definitions. So differential equation which are composed of an unknown function and its derivatives. So let us see the difference between what is ordinary differential equation and what is partial differential equation. First is ordinary differential equation. When the function involves one independent variable, the equation is called as ordinary differential equation or shortly known as ODE. When an equation involving two or more independent variables, then it is and its differentials, then the equation is called as partial differential equation and shortly called as PDE. Next is order. The order of highest derivative used in a differential equation. So if we have d square y by dt square, then it is of order 2. Next is degree. Power of the highest derivative which is free from rationals and radicals in the differential equation. So we have seen the order, and what is it? If the power of d square y by dt square is 1, then the degree is 1. If d square y by dt square's power is 2, then the order degree is 2. Here are the two examples. D square y by dt square plus dy by dt equal to 0. In this, the highest order is d square, therefore order is 2, and the degree of that highest derivative is 1. So the degree is, power of the highest order is 1, therefore the degree is 1. When you consider the second equation, dx divided by dt equal to x into d cube x divided by dt cube. Here the highest derivative is 3 and its power is 1, therefore the degree is 1. So next is solution of first order differential equations. Here there are 5 equations. So first one is variable separable equations. Second one is homogeneous and non-homogeneous equation. Next is exact and non-exact equations. Next is linear equations and Bernoulli's equations. So first let us consider variable separable equations. General form of differential equation is f of x comma y dx plus h of x comma y dy equal to 0. Here on using the variable separable method, we can separate the variables and write it together. So first, f of x comma y can be separated as f1 of x comma f2 of y, and here h of x comma y can be separated as h1 of x and h2 of y dy, which is equal to 0. Here we have to bring the variables together. Therefore, we are taking f1 of x divided by h1 of x dx plus h2 of y divided by f2 of y dy equal to 0. So now integrating this term will give the solution of the equation. Next is homogeneous equation. The condition of homogeneous function is f of lambda x comma lambda y power n equal to lambda power n f of x comma y, where n is the degree of the homogeneous function. Then dy by dx will be equal to f of x comma y divided by g of x comma y is the homogeneous differential equation if f and g are homogeneous functions of same degree. Then this can be solved into separable form by substitution of y equal to vx. Therefore dy by dx will be equal to v plus x into dv by dx. So if degrees of all the terms in the equation are same, then we call that equation to be a homogeneous equation. That is, highest derivatives order should be same. Next is exact differential equations. That is m of x comma y dx plus n of x comma y dy equal to 0. This can be also rewritten as m dx plus n dy equal to 0. The required condition for exact equation to be exact is dou m by dou y will be equal to dou n by dou x, and its general solution is integral m dx plus integral n dy equal to c. Now this y is a constant in m of x comma y, and n terms are free from x. Next is linear equations. The standard form of the linear differential equation is dy by dx plus p of x into y equal to q of x. This is a linear equation in terms of y. Here, if the power of the equation is 1, then we call the equation to be a linear equation. The integral factor that convert linear equation to exact equation is this integral factor can be rewritten as if, which is equal to e power integral p dx. First we need to find the value of integral p dx, and we have to take the exponential of that term, which will give the integral factors. Then the general solution of linear equation will be y into if equal to integral q into e power integral p dx plus c. Next is Bernoulli's equation. So the equation of the form dy by dx plus p of x into y equal to q of x dot y power n is said to be a Bernoulli's equation. So first we have to divide the Bernoulli's equation by y power n, so that we could get 1 by y power n dy by dx plus p of x into y power n minus 1 equal to q of x. Next we have to substitute z equal to y power 1 minus n. So on substitution we could get 1 by 1 minus n into dz by dx equal to 1 by y power n dy by dx. Next, on integrating we could get the solution. Thank you.